Hey guys, this is Steven Mossberger again talking about general hardware development and uh, hardware product development. So recently in our last video we talked about SLS for all and this ANOVA system. And if you guys don't know, I teach on Udemy Fusion 360 and some other subjects as I'm very familiar with Fusion 360, been using it for a long time. And so recently I was setting up an introductory video for a new class for a new project that I'm working on, Intermediate Fusion 360 project, and I'll link the course in the description. But one of my students requested that we do a robotic arm, and so I found this one on GrabCAD library, and so I wanted to just kind of show that for you guys. So basically, here is the GrabCAD library link. So the guy is Lucas Bojarski something, and this is the most popular one on GrabCAD for a 6 DOF degree of freedom robotic arm. You know, a lot of comments, a lot of likes, and also very clean on the download. And the reason why I wanted to show this is the style of BOM that is inside of the CAD. We'll talk about the BOM that's not inside the CAD that's supplied. I don't know if you got halfway through and stopped, but we'll take a look at it. So, um, and I talked about that in the SLS for all video, and that I was going to do something for that one. I will still do something for that one, and maybe even the BOM for this one to kind of show. But I wanted to show the structure of how this is set up and how this is kitted, with each component kitted, and how it makes logical sense for it to be kitted that way. So, downloaded it, and then it's got inside here, it's got the step file for it. So let's take a look at it. I'm going to use my 3D connection Space Mouse. This is a very old Space Mouse, so when I let go, you see it jitter like that. It's because the Space Mouse is bouncing, and it doesn't center as much as it used to anymore. This Space Mouse is very old. It's from like 2006, 2007. Anyways, so as you can see, very detailed. Very detailed model. Has uses linear actuators. There's 6 motors, and also a very complex head drive, where 2 motors are working in tandem to either pitch the head up and down or to rotate the head. So this is pretty unique to not have motors attached to the end effector and have the motors move around and worry about cables getting pinched and all these things. So if you count all the motors, there's 6 motors. Um, but mainly we're here to look at the kit. But you can see very talented mechanical engineer to be able to go in here and design all these things. Obviously, I don't think there's any sort of assembly instructions or anything in there, but we can take a look through the file and see what's in there. So I just wanted to showcase this great work, and also to show the structure of kind of what I'm talking about is a proper um, BOM inside of a model. So here you can see on the hierarchy on the left hand side, it basically has how he has it kitted is it's kitted by links. So very logical. Okay, you got link one, there's basically 6 links, including the base. So 5 links and 1 base. So that's the six. So that's 6 degrees of freedom. So it's broken up in at the joints of the degrees of freedom. So for example, here in the base, you can see that it has just the base, and it has all the screws for the base in the kit, all the components, the motor, the brackets, all the nuts and bolts, and all the hardware required for that segment is in that segment. Obviously, not wires here. Wires are not modeled. The belts are modeled, but wires are not modeled. So next, let's look at link one. So here, link one is the next degree of freedom. It's actually kind of the previous degree of freedom and the next degree of freedom. So right here is not modeled, but I guess there's some sort of belt where it twists. So the belt is here, and then it twists this way, I think, or something like that, or maybe some sort of chain where it changes to perpendicular some sort of flexible belt or something like that. And then this is some sort of pulley here. And then this guy attaches to the desk with a thrust bearing or something. Anyways, so basically here is like from the first degree of freedom and then up to the second degree of freedom, and you see it's got all the cotter pins and everything, and see how it's got separation. So there's a separation between this motor, which actually the interesting thing is this motor is for this degree of freedom, right? So uh, basically, how he did that is now he has that actuator here. These two actuators are separate. So sure, maybe that would have made sense for you. You could make the argument that that should have been inside of this link one, because this is controlling that first degree of freedom that pushes this leg up and down, this link up and down. So next one, we see the next leg. You see it has everything in there, obviously except for the actuator, and also all the connections to the actuator 1 from link 1. So this is link 2. You can see it's got all the hardware there. And here is where you get the interesting bit. It's like, okay, how do you do the shaft? Looks like the shaft is part of the next link. So there's this hard brake, and the brake makes sense here. So like, okay, well, technically, this little shaft is attaching link 2 to link 3, or in this case, link 3 to link 2. So that's how he's going to do it. But man, look at the detail. Even it's got the snap rings, right? Snap rings, all the washers, everything, right? So next one, link 3. So here you see link 3. It's got this next actuator all the way over here to actuator 2. And this actuator is the first one to be attached into a link. So you see it here. It's attached here. It even includes the shafts. Shafts are there, and it looks like another snap ring there, snap ring on the other side, and yeah. So then you see the screws. All the screws are there, and then this is some sort of coupler, torsion coupler, or some. Yeah, I think it's a torsion coupler, some sort of torsion coupler slash thrust bearing to keep the force off of the motor, so that you can take more load here. So the load is on the thrust bearing here, and also it looks like it's got a radial bearing shoved up in here, right? So it has all the components. You drop this down. It has, oh, okay, interesting. It's even got all of the screw dinning, right, and all of these different things, and so also it's very very welly titled. You see here it says where it's from, link 3, and what it is with description, description, description. So if I went in and created a drawing off of this assembly drawing, it's going to make a lot of sense. So I can do a link 1, link 2, link 3, link 4, link 5 bomb and drawing very easily, right? So I mean, this is really 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 good work, right? And this may not even have been done in Fusion, but very very good translation. So here you can see up to the torsion coupler here, and you can see how these are held in to basically it looks like this is kind of like acting like a thrust bearing, so it may have some back and forth here, and then yeah, it's held between these two bearings, and you can see it didn't count as this one, so he basically had this one into link 3 and then this one be link 4 because it's connected to link 4. Again, it's you can kind of argue back and forth about how that should be set up. So interesting here. So basically the pins itself, so this may be a what's it called, set screw or something set up for the bevel gears. So he has the bevel gears here, and again, these are the two motors. One spins count. I think what happens, one spins counterclockwise, one spins clockwise. If you do that, this guy purely moves up and down. This joint right here just goes up and down for this arm. If you have one rotate and one not, or both of them rotate in the same direction, if you have both of them rotate in the same direction, then this rotates, right? And then you have both of them rotate in the opposite direction. This rotates in the opposite direction. So pretty cool that this has a nice and lightweight end effector, so you can increase your load. But as you can see, very beautiful here, link 5 exact. So when I'm going through this, it is basically exactly how I expect it to be, except for sometimes you have the difference between the two links may be a little bit different than you would want it to be, but this is exactly how I would expect it, and it would be the easiest to document because it's like, okay, let's build the base. Okay, let's attach link 1 to the base. Okay, let's attach link 2 to the base. Okay, attach link 3 to the base to link let's attach link 3 to link 2. Okay, let's attach actuator 1, actuator 2 to link 2 and link 3, or link 1 and 2. 1, 2, and 3. 1, 2, and 3. So link 1, 2, and 3, let's attach the actuators there. And then, okay, I'm on to, link 3. Okay, let's attach the motor here and then attach everything together to get it to work. So this is how this is how a model should work. And you see it's very, very flat here. So we have, only what, 1, 2, 3, 4, 5, 6. It's basically 6 kits and 2 actuators sticking out. And then you have 2 of these bevel gears, the 2 bevel gears on the ends, right? Anyways, so very, very clean here. But let's take a look at what the BOM looks like inside the document. So here I've loaded it into Google Sheets just to see if, hey, is this actually an issue that I see? So you see that basically it doesn't have this is so it's here in the tab at the bottom. You got base link 1, link 2, link 3, and you can see it's kind of looks like it's not really finished, right? Maybe I'm wrong, but it seems that it's unfinished. I would have to check. Okay, so he's using a brushless DC motor. Here's the part code, stuff like that. So unfortunate, right? I mean, maybe it is, or he's has it in such a way. Right now, this is the actual native file. He's using an open document sheet, which I have, right? So here's the same thing. You see the tabs at the bottom. So again, it would have been nice if this was flat. So just have one tab and then have, and then just do a merge and then have, okay, this is link 1, base, whatever, if that's how you want to do it. But again, it's already kitted, so you can just put ideally your BOM would look just like this: base, link 1, link 2, link 3, link 4, link 5, link 6. So it'd just be like this, right? So it'd just be base, link 1, link 2, and then you would have this be like level. So this would be like level, and then this would be, you would have this, you'd have like level, and then this would be 0, and then you would have this be like, what is it, arm. So this would be like your arm v 1.0.15 or something. And then all of these are like level 1s. So these are your level 1 kits. And then you would have inside of here, so this example, inside base, you would have, screw, arm, and then maybe your arm has inserts in it or something. So then you'd have level 3, 10, 24 insert, um, you know, or dowel pin, right? Something like that. So that way, when you're done with the BOM, when the BOM's all collapsed, you have just these. So it makes it also easy to navigate your BOM so that generally, like I said, how you have it sorted. And again, I need to show an example. Maybe in the next video, I'll show an example of a collapsed and uncollapsed BOM. So generally, you can have it collapsed such that you can group things together, and then you could click for example, in Excel, you click a little plus, and then it opens up. So for example, I would have just all. So let's say I don't want to see any of this stuff from base. I want to look at link 1. I can hide all this stuff, and then it just becomes a flat BOM again. Base, link 1, link 2, link 3, link 4, link 5, and then actuator 1, actuator 2. So that way I only need to really look at what I want to look at the time. So he's kind of doing that here. This is one way of doing it. So here's basically he has his overall assembly, and then you have these different tabs that you can go in between. It's just a little easier to have one tab and have the level. But if your software that you're using, your Excel-based, sheet style software doesn't have that collapse and uncollapse, then you can do it this way by having tabs. But imagine you have 30 of these. The tabs gets kind of daunting to navigate through the different tabs or sheets in this case. So it's a little for something like this is okay, but as it gets bigger, this gets a little unruly because it gets harder to read and then also harder to navigate and harder to tell which one you're in without having without looking down here or having something in there to tell you. So yeah, and then this is what his file looks like here. So um, right, so I open the arm step and then you know so it looks like it was part of some designs accelerator. I think that what's it called? I think that GrabCAD library puts those out sometimes, those accelerators. And yeah, so you can see some of these different things. So this was that main file right there. And then inside each of these, he has all the different IPTs, which are basically like, so I guess this is Inventor because Inventor uses IPT file. I believe either that one or SolidWorks. I can't remember. So anyways, I just wanted to show you guys what I believe is basically a perfect. I'm gonna say it's perfect. It's a perfect Fusion 360, or not even Fusion 360. Any sort of CAD system, any sort of CAD system, flat bomb, right? It's very easy to navigate. If I say, oh, I want to look at all the parts for link one, bam, there they are. Oh, I want to look at all the ones for link two, bam. If I'm doing documentation, how do I write a procedure on how to build this, either manufacture in house or sell this thing as a kit? Very easy because I say, hey, here's my bomb. You see all the different parts, and that corresponds to the parts that I'm looking at in the model. And also, you can supply the model with the kit. Okay, so now I can go through and navigate all these, right? And it makes it very easy to go through and navigate for even if you're the designer and then you have somebody else do the documentation. It's very, very easy to do it this way. So you can see all the benefits of having it arranged this way. It just looks very clean, very professional, and easy to do all the documentation, all the post steps, more than just the modeling. Now, of course, you can always do this where you create an open part and then shove everything in there. So you can do this all at the end. You can fully design it and have piece parts everywhere and then have this be like 300, 400, 500, 5,000 pieces long and then keep dumping stuff in there. Obviously, it's easier to start that way from the beginning, but that's also something that you can do. So, anyways, just wanted to show you guys this. I caught it in my when setting up for my class, so I wanted to show it and show you guys what a good example looks like. Anyways, good work to this designer, Lukas Bojarski. Very, very good. Very, very good work. And I will see you guys on the next video later.